This is 2024 time zone 2 AAHL paper 3. Paper 3, question 1. So it's like, I don't know, one of those memes question, I guess. What if the product rule is just you differentiate each of the function? All right, so the question is like, when can you actually do this? All right, so let's start by giving you an example where this is actually possible, just by coincidence, I guess. So there's a f and a g. You're asked to find the derivative of f. So f is 2 minus x to the power of negative 2. So if you do chain rule, it's negative 2 x minus 2 to the power of negative 3, and then times differentiate the inside, which is minus 1. So it's 2 minus x to the power of negative 3. Hence, f prime g prime would simply be f prime, which we just found, times g prime, which is 2x. If you differentiate g is 2x, which happens to be this. On the other hand, if you do product rule properly, then it's f times g prime plus g times f prime. Somehow you'll get the same thing. So you're supposed to show a little bit of working to convince the marker that you didn't just write down the answer, because the answer is given, right? So you have to show some working. So the 4x minus 2x squared. But of course, it is indeed what they suggest it to be. So this will be one example where doing product rule is the same as just differentiate each of the thing and multiply them together. Consider some function fg such that g is not the same as its own derivative. By rearranging this meme, okay, it's not really a meme, but show this. So we start with the left hand side, I guess. Oh, no. This is not proving left hand side, right hand side. You start from this whole thing. So you can rearrange this. So I think the fastest way is you subtract this to the other side. Kind of don't want to keep writing the x. The x is like pretty useless, right? Here you have f prime and f prime, so you can factor out f prime. So what's left? It's g prime minus g. And they want f prime over f, so we'll divide this f away. So f prime over f will be the same as dividing this away, g prime over g prime minus g, which is what they want. In your exam, I don't think you can skip writing the x. It's just that I'm lazy, so don't do that in the actual exam. Then part C is kind of solve the differential equation. So you integrate both sides. So you integrate f prime over fx. You integrate the right hand side as well. So the key is seeing that the left-hand side can be done by a substitution, because in some sense you can let u be f, then du dx is just f prime. So dx would be what? Du over f prime, or you can do substitution in the way that you like, or you can even skip the process of doing substitution if you can just see the integral, which is possible because this is quite a basic substitution. cancel out. So integrate 1 over u is ln u. Cancel with plus c equal to the right hand side. So nothing happened on the right hand side, we just copy. And u is fx. Then we'll take away the c, I think. And then to get rid of the log, with e the other side. Just e to the power of that whole thing. Again, I will stop writing x, so boring. Minus c. So first you have e to the power of minus c. That's the same as having e to the power of negative c times the rest. Right, due to law of indices. Second, you can make the plus minus go away. So it's plus, make the absolute sign go away, which means you plus minus the right hand side. So you can replace this by a constant, because plus minus e to the power of a constant is still just a constant. And that thing. So tell people what a means. Then I think that's what they want. Yeah, it's pretty much what they want. Oh, did it say a is positive? Oh, the reason being fx is positive, which means the absolute sign was unnecessary. Because f is definitely negative, so you don't have the absolute, which means there's no plus minus, just plus. Well, but I don't think that condition is needed. And what's next? Use the result of C. The result of C can be used to find function which satisfied both. Yeah, so to find function where doing proper product rule is the same as just multiply, right? Use a to be 1. If gx is this, find fx. So according to the formula, fx is a is 1 now, times e to the power of the integral of what? G prime over G prime minus G. G prime over G prime minus G. 1 times anything is just a thing. So G prime will do proper product rule. So is copy the first, differentiate the second, plus differentiate the first, copy the second, over the same thing, because it's G prime as well, minus G. So let's see what that is. The top, we'll keep it. The bottom, they cancel out, so it's EX, and then the EX cancel out. This is 1. So it's the integral of x plus 1 on top. X squared over 2 plus x. Do we care about the plus c? I don't think we care about the plus c. Yeah, because if you remember from solving the differential equation, the c is really part of the a, right? So we don't need c anymore. So I think that's f. E, considered that gx is sine plus cosine, find f. So I think we're doing the same process. So E, so fx again is a being 1, e of g prime. If we differentiate sine x plus cosine x, it's cosine x minus sine x over what? G prime minus g. So be careful with the sign. So I guess we'll do this again. Integrate. We'll simplify the bottom. Cosine cancel out, so it's -2 sin x. So I guess we need to figure out how to integrate this. We'll separate the sign. I mean, we'll split the denominator into like this. So this is what is -1/2 of cotangent plus 1/2. So I guess the key is just how to integrate cotangent. Well, cotangent is cosine over sine. You do a substitution. You let u be sin x, right? Then differentiate that is cosine. So dx is du over cosine. So this should be quite a basic substitution. Cosine over u, du over cosine x. So they cancel out. Integrate 1/u is ln u. U is sine. So this is -1/2 of ln sine. Plus integrate half is half x. Again, we don't need plus c. So this is fx, supposedly. They want ex. They want the answer in the form of ex times h. So first, I think the square root come from the half power. So half power is the square root. Then we have e to the power of -ln times e to the power of x, because if you add in the power, then by law of indices, it can become times. So we move ex to the front, times this. We put the negative up in the power, so it's sin x to the power of -1. Then the half power is square root. E to the power of ln cancel each other out, so we have sine to the power of -1, which is 1/sine, right? Not the inverse, but 1/sine. 1/sine is cosecant. So that's the answer, right? So I think question 1 is quite okay. It's not too boring. It might, some of the parts might be a little bit confusing, but if you take the time and like work around it a little bit, most likely it's doable. It's quite doable.